Form 4. Form 4 is year 10. Chapter 2, physics. The name is similar to what we have learned last week. It's force and motion 1. Last week one was force and motion 2. Last week was Form 5, which is more advanced. This week is Form 4, which is 1 year before you start to learn the one that we learned last week. So this is supposed to be an easier subject, easier chapter compared to last week, or compared to before Chinese New Year. Right. So let's jot down what is the starting time. We started at 6:07 a.m. Right. I hope everyone remember we have steps to follow. In these 2 to 2.5 hours, we have steps to follow. There are about 10 steps. So step number 1 is to create the drawers. So these are the 5 drawers that I've created. By the way, you can see my screen, right? You can hear me, you can see my screen, because we are going to start this 2.5 hour journey. Can I get a show of hand just to make sure, double confirm? You can see my screen, you can hear me well. Okay, I got it from Xingling. Isa is Xingling. What about, okay, good. So let's start. Okay. Step number 1, create the drawer. I've created 5 drawers. Linear motions, Newton laws, momentum, gravitations, impulse. How do we remember these 5 drawers? I created this very simple story. Lina, new mom, gave invitation card. I kept in my purse. So you can imagine, if you have a friend called Lina, then it's perfect. If not, just imagine a new friend with some interesting features in her, so that you can remember her better. Whether she has a very big curly hair, whether she has a very big mouth, whether she's have a very big arm, muscular Lina. Okay, but what's interesting is her new mommy gave an invitation card to you, and you keep it in your purse. Right? Lina, new mommy, gave invitation card. I kept in my purse. Lina represents the linear motions, to help you to remember the linear motions. New represent Newton, right? Newton. Mommy is momentum. Gave invitation is gravitation. I gave invitation card. I kept in my purse. Purse is in my purse is impulse. In my purse, impulse. Right? Now, if Xingling and Aiden, you can take out a pen or a paper, a pen and a paper. Just write down this very short sentence. All right, just write down this very short sentence. Hi, Marcus, we just started. Okay, you can continue from here. Okay, Marcus dropped again. It's okay, doesn't matter. So write down this very short sentence, which is a story for us to remember these 5 drawers. Lina, new mommy, gave invitation card. I kept in my purse. Right. So I'll give you 20 seconds. 20 seconds to write this down. Write it down in your in a paper. And paper needs in front of you all the time in these 2.5 hours. Right? Okay. Yes. Why is this important? Why is this short sentence that is translated into a story important? Is because we will need to use this story to help us to remember there are 5 drawers and the name of the drawers, and these are the anchoring point. Remember, I told you the brain, human brain needs an anchoring point. So this is the anchoring point. So you have to create this anchoring point for you, so your brain can focus has a laser sharp focus on each of the steps that we're going to follow through later, right? Just now, a while ago, we did a revision. That revision, if you realize, the first step is for us to remember this story, right? So once you remember this story, just like the class that we attended before Chinese New Year, it helps us, the one that is related to the SPM and the result, you got the SPM result and your 2026 resolution is the same as 2025 to become a plastic woman. And that very short story is helping you to remember the drawer. Once you remember that drawer, the 4 drawers, remember, not this one, the 4 drawers, and then that will help you to anchor your brain. Okay, what is inside resultant force? What is inside resolution forces? What is inside equilibrium? What is inside elasticity? And that forces your brain to start to focus on resultant forces. What is resultant forces? And if you you are able to have a photographic memory on the picture that I showed you just now, the direction of the GPS, the new mummy, and that's exactly where you're going to get the information, what you have learned in that particular drawer, right? Then drawer number 2, drawer number 3, and drawer number 4. Okay. Now come back to this chapter. Okay, that's step number 1. So step number 1 is done. So let's go to step number 2. Step number 2, as usual, you have to read this this part over here. But as I say again and again, don't worry if you do not understand fully what is written over here, because you understand it as we progress along. Okay, so I'll give you 1 minute. Okay, 2 minutes to read from drawer 1 until drawer 5. Okay, let's start now. Oh yes, before that, sorry. The one in the bracket, it might you can ignore it, right? The one in the bracket is the story that we're going to use in the following in the further steps. So now just read everything except the one that is in the bracket. Okay, let's start again. 2 minutes. Start now. Sorry. Ready? 8 seconds. 10 seconds. Okay. Now, how do you read this? We have drawer number 1, drawer number 2, number 3, number 4, and number 5. Right? It's the same format where we have our step number 1. So each of these drawers, you have some informations. And this information is related to for drawer number 1, this information related to linear motions, where you have key quantities: distance, displacement, speed, velocity, accelerations, right? And then you have different type of graph of the concept when it is at rest. Uniform velocity, what is this? Uniform velocity and deceleration. And then what type of graph? You have a graph of displacement over time. You have graph of velocity over time. You have the graph of acceleration over time. Then you have some experimental tools and equations. Don't worry about this equation. Do not need to memorize. It will be given in the exam if you are taking SPM, but you just need to know the concept. This equation is used when you have uniform accelerations, right? This chapter particularly, especially this drawer, you need to remember this. You need to remember these 5 quantities, right? How do I remember this 5 quantity? I'm using this story. In Chinese, little brother, we call Titi, right? So Titi, speed. So he's running, speeding to city of Alexandria. Alexandria is a city in Egypt. And along this journey is high slope and muddy area, right? So Titi speed to city of Alexandria. Just this very simple sentence is helping us to remember these 5 quantities. So if you are worried about remembering these 5 quantities, don't worry. This is how we are going to remember this, right? Because these 5 quantities is very important for us to remember and to understand, as these are the fundamental of this topic, this chapter. So TT is distance and displacement. TT, distance and displacement. Speed obviously is speed to city of Alexandria. City is representing velocity. Alexandria sounds like accelerations. I hope that can ring some bell. So that city is speeding to city of Alexandria. Itself is able to help you to remember these 5 quantities, right? So drawer number 2 is about Newton law. There are 3 laws, right? So what you need to know is there are 3 laws related to Newton, which we're going to learn later. Law number 3 is momentum. Momentum is related to the collisions and explosions, right? And there's this formula over here. Number 4 is gravitation. So gravitation, you have free fall and you have mass versus weight. What is mass? What is weight? If you understand what is being written over here, then congratulations, good news for you. If you do not understand, it's fine. You just need to know there's something related to mass and weight that you need to learn later. And also free fall. What is free fall? And then drawer number 5, impulse. So you have impulse and impulsive force. So there are 2 key points that you need to learn later. If you understand this now, congratulations. Next few steps is revision for you. If you don't, it's fine. You just need to know there are 2 important keywords that you need to know for this drawer number 5. So all in all, there are only a few key things you need to know for each of the drawers, right? Drawer number 1, maybe you need to remember this, but we have already covered that by just having this very simple story. TT speed to city of Alexandria, right? So that is step number 2. Okay, so let's go to step number 3. Okay, so how do you read this step number 3? I think this is not the first time you attended my class, but I will repeat again. How do you, what is the technique that you use to read this? So in case you've forgotten, right? So number 1, when you read this, intentionally ask yourself, which drawer is this? I know it is very obvious. It is written here, drawer number 1. But when you tell yourself and ask yourself this question and answer it by yourself, then you remember this drawer more, because most importantly is to anchor, create the anchoring point, and the anchoring point is our drawers, right? Once you read this, ask yourself which drawer. This is drawer number 1, linear motion. Then if you realize this part, number 1 is number 1 here. Okay, number 1 in our step number 2. The difference is it is having more elaborations. Okay, it's having more elaborations. So by reading this small paragraph here, you should have new informations that you never know before. 10 minutes ago. 10 minutes ago when you just read this draw number 1 in step number 2. Okay. So we are building our knowledge as we progress from step number 1, number 2, number 3, number 4, number 5, until number 8, right? So let's do this exercise and do this drill, and we will have, okay, let's do 1 minute for this very simple paragraph. Let's start now. Fifteen more seconds. Right. Now, there are definitions and there's a type of quantities. They have scalar quantities and vector quantities. So it's very clear, also written over here. There are 2 scalar quantities and 3 vector quantities. Scalar quantities and vector quantities was different. Vector quantities is the quantity that is having direction and magnitude. Magnitude and direction. Scalar is only having the magnitude. Right? Later if you understand what is the difference, then also excellent. If you don't worry. You're going to learn this as we progress along. You just need to know there's something scalar and vector that you need to know in this particular drawer number 1. Okay, so let's go to drawer number 1 for this point number 2 and number 3. Okay, and as you read this, you have to use this as a reference, your step number 2 on this side as your reference. Then you see, okay, yes, this is about this concept. This is the things that I need to understand. But when you read step number 3, this is more elaboration. So there are new information you need to understand about this point, drawer number 2 and 1 and point number 2. Let's do 1 minute for this point number 2 and number 3. Let's start now. Right? So you have done the displacement versus the displacement over time graph. And let's continue from velocity until this acceleration. Let's start now. right? Yep. So there are. This is the summary of how you remember these three types of graph, and the important points are what is the gradient for this graph. The gradient for this graph number one is representing velocity. The gradient for graph number two is representing accelerations. And then the area below the graph is displacement for velocity over time, and change in velocity for acceleration over time. Let's do this for 1 minute. Let's start now. Experimental 2 until here. I think 30 seconds is fine. Five more seconds. Right? So this is drawer number one. For those who can understand fully what drawer number one, excellent. If not, which is most of it, which is normal, right? What you need to know to take away from this 10-15 minutes is there is drawer number one, and it's called linear motions. And the name itself is giving you some idea what you are learning in this drawer number one about motion, and it's linear. Linear means straight line. And there are some quantities that you need to remember over here. And we have this very simple story to help you to remember. TT speed to city of Alexandria, right? Then you have a concept that you need to understand a bit about the graph. And then there's this graph of the three type of graph that you need to learn later, right? And which are the important parameters, gradients, and areas of the graph. Then you have some experiments, and there you have these equations for uniform accelerations. Okay, uniform acceleration, right? So next, again, don't worry if you do not fully understand. We just started our lesson. We just started maybe 20 minutes ago. So 20 minutes, and you can understand that there are uh, uh, a few key things that is in this draw number one, and that is really a good achievement. Right. So let's continue on draw number two. So you can use this here on your right as a reference, and then read this as you are using this note on your right as a reference, and read this as a more elaboration information that you need to learn from draw number two. And draw number two now is the law of motion, Newton law. So now there are three laws that you need to learn. So what are those three laws? I'll let you to discover this by reading this for, let's do 2 minutes, because this needs a bit of think. Thirty seconds. 10 seconds. Right? So the three laws over here, Newton laws, inertia, force and acceleration, action and reactions. Inertia, force and acceleration, action and reaction. That is drawer number 2. Drawer number 2, right? So drawer number 2, the name is Newton law. Drawer number 1 is linear motions. And in the story, and the story that's right in front of you, you just written down in an A4 paper. Lena knew Mommy. Mommy, we're going into it later. So now Lena knew is the two drawers related to the story. Let's go to drawer number 3. Okay, we're gonna go a bit faster as we progress, as we follow the steps. Okay, this one, let's take, okay, here, until momentum. Drawer number 3. Let's take 1 minute. Ten seconds. If 1 minute is too long, then you read it again and again, right, to fully utilize that 1 minute. Okay, gravitations. And in the story is new mommy gave what? Gave invitation, right? A birthday party invitation or whichever invitation that you want to be, right? Gave invitations. So draw number 4, that's number 4, related to free fall, related to weight versus mass. Let's do 1 minute. Fifteen seconds. All right. Now gave this meeting, this invitation, and what do? You kept it in your purse. In your purse is impulse. Impulse. So impulse. So now we are in drawer number 5, right? Drawer number 5. Let's do one minute for this. Drawer number 5. Read from drawer number 5 until off the ball. Okay, done. All right, let me emphasize. Remember, in the previous lessons, in previous class, I told you I'm not your typical teacher. I'm not teaching you physics. I'm teaching you a study method. And if you realize, I do not speak 80% of the time. In fact, most of the work is being done by you. 70, 60%, 70% of the work is being done by you. So I'm here to teach you the study method. And I'm facilitating you now from step 1 until step 10. Now we are in step 3, right? If going through this all the 10 steps, I think as you already see the results, after 2.5 hours, you'll be able to understand this chapter pretty well, right? Just like what you did for the last chapter. I think most of you got 9 out of 10 or even 10 out of 10. 10 out of 10 questions correct. Now, let's do this. Step 2, right? Step 2. If you read this quickly, again, you feel that you understand step 2, the content of step 2 more now, right? Let's do it for 30 seconds quickly. Read from here, drawer 1 until impact. 30 seconds. 1 seconds. Right. So I believe that you feel that compared to 20 minutes ago when you first read this and comparing to now, when you read it now, you have more understanding, right? I did not change anything inside this drawer, this step number 2. The only thing changed is after 15, 20 minutes, you read, you follow step number 3, and that's where you are able to understand this more, right? So imagine if you are in step number, the more advanced step 4, 5, 6, or 7, or 8. Obviously, if you come back and read this again, you will have a much better understanding the first time when you read this. Now, so you remember, now you need to, definitely you need to remember this, there are 5 drawers here, right? And by now you have to remember the name of the drawers. The paper that's right in front of you is to have the story that's in front of you that's supposed to help you to remember these drawers, right? And what are the stories? This Lina, new mommy, gave invitation card. I kept it inside my purse, right? So just by looking into this story, very short story, the first drawer is linear motion, second drawer is Newton law, third drawer is momentum, fourth is gave invitation, which is gravitations, sorry. Then drawer number 5 is I kept it in my purse, impulse, right? So let's go to question, step number 4, right? Step number 4 is, how do you do step number 4? When you read these questions, ask yourself, which drawer is this? I'll give you a hint. Usually, there are 8 questions, and this 8 questions is being arranged in sequence. So usually, question number 1 is drawer number 1. But I need you to intentionally still ask yourself and provide your own answer before you read the question, read the answer of the questions, right? So let's take one example. How do physicists differentiate between distance and displacement in describing an object path? So this is drawer number 1, and it's talking about distance and displacement, right? Drawer number 1 is linear motions, right? That's all you need to do. Then when you read these answers, ask yourself if there's new information that you did not know before after reading step 2 and step 3. If yes, intentionally pick it up and put it inside your brain, right? If there's new information. If no, then take it as a reinforcement learning, right? Okay, let's do this. This is the drill that we're going to do, and this is not the first time you have done this. I believe you can follow this quickly, right? So we're going to do question number 1, FAQ 1, until origin in 1 minute. Fifteen seconds. All right. So we'll continue. Question number two. Question number two. I'll give you 1.5 minutes. This is a bit tricky. Let's start now. Question number two is drawer one, linear motion. Fifteen seconds. Right. So this is drawer one equations inside this point number 5. I hope by now you can appreciate these 4 formulas right now more. Okay. If not, don't worry. You just need to know a little bit more than what you have done 10 minutes ago, and that is already fine. Because you're going to know a little bit more 10 minutes later, then a little bit more 10 minutes later. By by another less than 2 hours, you know quite well what is in this drawer, right? So let's see whether this is still drawer number 1 or drawer number 2 in 1 minute, FAQ number 3. Let's start now. Thirty more seconds. Ten more seconds. All right. This is drawer number 2. Because talking about Newton's first law. And not second law, not third law, but first law. First law is inertia. I hope by now you know what is inertia. You know what Newton's first law about, right? And okay, now we are in FAQ number 3. After FAQ number 8, we will have a quick break. So toilet break or water break. FAQ number 4. Which drawer is this? And let's start now. Okay, a mass of M. Yeah, I missed the symbol. Right? So by now you have a little bit more understanding about what is drawer number 2, Newton's second law. Okay. Question 5. Let's start now and ask yourself which drawer is this? Ten more seconds. Right? So this is drawer number 3, the momentum, the new mummy, the mummy. Right? And it's talking about momentum. It's talking about the collisions and explosions. And now I think there's new information is about the safety dynamics. This is not being known before in step 2 and step 3. So this step 4 with the new information. Right. Question number 6. Free fall. Free fall is drawer number 4. Let's start now. 1 minute. Gravitations. Uh, sorry, this XXS, there's a numbers here. I missed. Okay. The equation and the post, there are two different numbers, different than 9.81. 9.81 is at the center, at the surface of the at the Earth on average. Equator, because Earth is not a perfect circle, it's a sphere. So when the distance from the center is further, then the weight is weaker, right? This is my mistake. Anyway, let's not disrupt the steps. I think it's not too important. Let's continue here. Start question number 7. Let's start now. Ask yourself which question, which drawer. Okay. Last questions. Let's do 1 minute here before we go for the break. All right. Let's go for a 5 minutes break. Then we'll come back after 5 minutes. All right, 20, 30, 25 more seconds. Okay. Is everyone back? Just to make sure. Singling and Aiden. Okay, Aiden is back. Singling, are you back? Yep. Okay. So what time do we start just now? We start at 6:07. Now is almost 1 hour, less than 1 hour. So less than 1 hour. By now, I hope and I believe that you are able to understand a bit more about what is this chapter. And you know that there are 5 drawers, and these 5 drawers are linear motions, Newton laws, momentum, gravitations, and impulse. And in linear motions, you have these key quantities. And how do you remember these key quantities easily? TT speed to city of Alexandria. TT is distance, displacement, speed, which is speed, to city. City is velocity. Alexandria is accelerations, right? And they are scalar quantity and vector quantities. Right? Vector quantity is a displacement, velocity, and acceleration, which later we use to define to learn the type of graph. Right? Then you have these 4 formulas, 4 equations, which is used to calculate uniform acceleration. Right? Then that is basically drawer number 1. Then drawer number 2, you have Newton laws, and you have 3 Newton laws. You have the first, second, and third. And I think by now you have more idea about what is first law and second law, because in the FAQ it was being explained and answered in quite detail. Draw number 3 is the momentum, which is the mummy, right? Mummy. And momentum, I believe also in the FAQ also describe a bit more what is momentum. Number 4 is the gravitations. Gravitations, where you have free falls and mass versus weight. Draw number 5, you have impulse. So impulse, you have impulse and impulsive force, right? So this is the key concept that you need to understand about these 5 drawers in these chapters, in this chapter, right? So before we move into the stories that can help you to reinforce what I've told you just now, the key informations inside each drawers. Let's do one more time reading it as step 5 to make sure that you really reinforce the new information, new knowledge that we have learned just now in 1 hour. Reading this guide, right? So how do we do this? It's the same thing. Ask yourself, which drawer is this? And then intentionally see if there is new information that you did not know before, and pick it up and put it into your drawer. Okay, so I'll do, let's see, 1 minute. I think 1 minute is enough. From drawer here until this formula. Okay, let me see. Wait, this is quite a long one. Okay, we'll divide it into 2 parts. 1 minute and 1 minute. Let's start now. Oh, so sorry, so sorry. What have I done? Yep. Right. Um, just now there's a hiccup over here in my computer. Are you still able to see the screen? Just to make sure. Aiden and Xingling and Marcus, are you still able to see the screen? Can I have a thumbs up? Oh, can you still hear me? Yes. Xingling, yes. Aiden, yes. Okay, good. Right. So we have done this part. Let's continue from where u is the initial velocity until Newton, until here. I'm going to scroll down a bit later, okay? So let's do 1.5 minutes from here. Okay, I'll scroll down a bit. Okay. Okay, 30 more seconds. Right. I hope it's enough. I'm not sure. If you need more time, let me know. If not, then we will proceed to the next one. Right. Now we are in drawer 2, Newton law, the new mummy, new. Right. So let's do drawer 2 until here, which is right before Newton third law. Oh no. Okay, let's do the whole thing 1.5 minutes. I'm going to slow down a bit more for you to read Newton third law. Fifteen seconds. Oh, let me scroll down a bit. Sorry. Yeah. All right. So this Newton first, second, and third law, how do you remember this easily using a very simple story? Let me review it. What is this story about? Right. If you see this part that I highlighted, fat lazy Irene forces Alex Mama repeatedly act cute. So there's this lady or this girl, which is fat and lazy. Her name is Irene. She forced Alexa's mommy, to act cute, to repeatedly like act cute, keep acting cute. Right. So what does it mean? Fat lazy Irene. Fat lazy Irene is related to first law. Irene is inertia. Right. Irene inertia. We're starting with the I. So I hope this makes sense. Fat lazy is because if you understand first law, the object wants to remain constant, whether it is not moving at rest or whether it is moving at a uniform velocity. It wants to remain that way, and that is the first law, right? So and also the heavier it is the object, the harder to change the status of this object. So that is the inertia. So fat is representing the mass. Lazy is representing the object doesn't want to move, doesn't want to change the status, whether it's moving at a constant speed or whether it's not moving, static at one point. And Irene is inertia. So fat, lazy Irene forces Alexa's mommy, right? So force and acceleration, right? Force and acceleration. That is forces, Alexa's. So force is force, Alex is acceleration. Mama, why mama? Because there is this formula F equivalent to ma. So this is help us to remember second law. Then third law, action and reaction, right? So repeating is reactions and act is actions. Acting cute, right? Just to create some emotion here. And this, in fact, not illogical story, but I think it does the job. So you can imagine you have a friend which is fat and lazy. Her name is Irene, and she forces Alexa's mommy to keep acting cute, to repeatedly acting cute, right? So you have inertia as the first law, force and acceleration as the second law, and action and reaction as the third law, right? So that is drawer number 2. So drawer number 3, okay, yes. Also 1.5 minutes. Let's do it now. This part. Thirty seconds. Ten seconds. All right. That's done. Momentum. Momentum. Anything need to be explained over here? We explain the story in the next step. Then you help you to remember the concept better. That's momentum. This one. Fat mummies runs towards each other and collide. Right. I think by now, by reading this story, I think you have some idea why I created this story. I'll tell you in detail later in the next step. Right. So gravitation and free fall. Let's also do 1 minute and 30 seconds. Drawer number 4. More seconds. If you finish reading it, you can read it again to make full use of the time. All right. So drawer number 4 is for free fall. I think by now you know what is free fall, right? Free fall is being done in assuming there is no air friction. That means in a vacuum. In a vacuum, if you have a feather and a very heavy ball bearing and they fall at the same time, you release it and they will reach the ground exactly at the same time. Okay, that is free fall. But the assumption is you need to do it in a vacuum. That means no air frictions, no external forces. Right? Then mass and weight. Mass and weight is quite interesting, right? We have been asking someone, what is your weight? And then they will tell you, I'm weight 50 kg. In fact, scientifically, that is wrong because weight is not in kg. Mass is in kg. Weight is in Newton, this unit, Newton kg minus 1. And mass doesn't change. It remains constant regardless of this location. But weight change. If you're in the space, then obviously your weight changes because the gravitational force is weaker. That's why you have this equator and poles, because Earth is not a perfect round, a perfect circular Earth. There are part that is having longer distance from the center of the Earth, and there are part that is nearer. So the nearer it is, the stronger the gravitational force. So on average, our gravitational force we calculated as 9.81. In the poles, because it is nearer to the center, so it's 9.83. Equator is further, so it's 9.78. But these are approximations. So let's go for the next one. So then we can complete step 5. Let's do 1.5 minutes. Let's do it now. Thirty seconds. All right. Okay, that is drawer number 5. No. Now let's go to step 6, create story, which I think we have done some of the drawers. Drawer number 1, let me just throw back this reference. This step 2 is always our reference. Right, step 2 is always our reference. Now, drawer number 1, TT speed to city of Alexandria, high slope and muddy area. So what does it mean? I think by now you know what is this. TT speed to city of Alexandria is to represent the key quantities: distance, displacement, speed, velocity, and accelerations. This story is to help you to remember what are the key informations in that drawer, right? Then high slope and muddy area. So when I draw this little boy is TT. TT is little brother. Speed on a high slope and muddy area to city of Alexandria. So this is city of Alexandria. Slope means gradient. Remember we learned about gradient. Different type of graph, the gradient is representing different thing, right? Displacement over time, the gradient is velocity. Velocity over time, the gradient is accelerations, right? Then the area inside below the graph for velocity over time is the area is displacement. For acceleration is change in velocity, right? So this very simple story and this very simple drawing helps you to remember, to anchor your brain into draw number 1, right? Draw number 2. Fat, lazy Irene forces Alex Mama repeatedly acting cute, right? So I draw a fat lady Irene using this stick to force Alex Mummy. Okay, I draw this Alex Mummy with the hair, curly hair. Usually, Mummy is curly hair. To act cute. So this is like acting cute, right? The hand is curvy, the leg is curvy, right? So with this picture alone, I think it's easy for you to remember what is the content of this drawer, Newton law. So there are 3 laws: inertia, force, and accelerations, because Alex Mummy, and then action and reaction, right? Action and reaction. Drawer number 3, momentum. Fat mummies run towards each other and collide, right? Why fat mummy? Momentum sounds like mum, okay? Mummies. That's why it's M-O-M-I-E-S. And then fat mummy, because momentum usually is related to the mass. The heavier the mass, the bigger the momentum. So fat mummies run towards each other. These 2 are the fat mummies. They run towards each other and collide. So this is to give us an idea, to anchor our brain, what is inside this drawer number 3. Right, we have collisions. And then you can also add in collide and exploded. Right, 2 fat mummies running towards each other and collide and exploded. Yes, you can add another one, exploded. Collide and exploded. Right, to make it more emotional, make it more funny. Draw number 4, gravitation. Big mass and small wind, free falling. Right, so I think you know why I created this story, because it's teaching about mass and weight and free falling. So big mass is mass, small wind is weight. So max is mass, wind is weight. Big and small is to reflect the heavy ball bearing, which is big, and also small, which is the feather. and they're doing free falling. They're going to reach the ground at the same time. Right. Draw number 5, Imran. I'm not sure whether you have friends called Imran. Right. Imagine you have a new friend called Imran. Imran make an impulsive push. Then the car crash. Right. Imran is to represent impulse. Imran, impulse. Make an impulsive push. Impulsive, obviously, is the impulsive force. And car crash. Car crash is, I think, the example that you have read just now in the previous steps. The car crash, if we reduce the time, and then they will absorb the impact on the passenger and on the driver inside the car. So that is to help you to remember why impulsive forces is important to calculate, to design a car that is safer, right? So these are the 5 drawers. I'm not sure. My advice is, if the pen and paper is still in front of you, you can quickly, using 1, 2, 3 minutes, to draw these very ugly pictures. Draw this out, and that will help you to remember the content of the drawer, right? I'll leave it to you, okay? Everyone comes to my class, it's not by force, but I'll leave it to you. I'll give you 2 minutes. If you want to draw, it's great. If you don't want to draw, just remember this story, or just write down the story. Right. Let's do 2 minutes. Write down the story and draw if you can. I think I'll give you full 3 minutes. 2 minutes is a bit short. So 2 more minutes to write down the story. And if possible, just quickly sketch it. I'll tell you why is this important after the timer. Why is the story important? And why is the drawing important after the timer? One more minute. Thirty seconds. All right, let's stop here. Like I promised, I'm going to tell you why is this important. All right, before that, let me tell you, let me ask you a question. Is it easier for you to remember a story? Or is it easier for, let's say this one. So there are 5 drawers. Is it easier for you, okay, for you to remember the name of the drawers by just looking at this, remembering this linear motion, Newton, momentum, gravitations, and impulse? Or is it easier to turn it into story that can help you to remember these 5 drawers name? Right? Obviously, it is number 2. The story that can help you to remember the drawer's name much easier than remembering this boring text, linear motion, Newton laws, momentum, gravitations, impulse. Compared to Lina, new mommy gave invitation card and I kept it in my purse. Right. Now, next comparison. Is it easier to remember this full of text or to remember this picture? And obviously it's number 2. It's easier to remember the picture. Now, maybe you do not fully remember the picture because you just get to know this story and picture maybe 10 minutes ago. But if you draw it like 5 or 10 times, it will be easier for you to remember this picture than writing this down for 5 or 10 times, right? Because our brain works better with pictures and stories compared to text. So now imagine you have this picture in your mind. Imagine you have already drawn this 5 or 10 times. And coming back to this drawing, coming back to this story in this drawing, is it easier for you to remember what you have learned for the past 1.5 hours? Right? And this one, and this one, and this one, and this one. Especially after 2 weeks or after 3 weeks, looking at this picture alone can already help you to remember what you have learned 2-3 weeks ago, right? So that is why picture is important. Now imagine you're in an exam room and you draw this out. Maybe it will take you 1 minute to draw this out. Almost immediately, you have a quick understanding of what is in this chapter. Any question that is being asked, explain Newton's first law. Immediately, you point out here, fat, lazy Irene. So immediately you know it is related to inertia, related to something about mass, and it's related to something about the lazy. What is lazy? Yeah, it is always trying to remain in constant, whether it's static or whether it's constant movement, right? So immediately you'll be able to explain Newton's first law, right? What if they ask you, why is it important in designing a car to understand the impulse and impulsive force? Then you can explain what is impulse, what is impulsive force, because Imran impulsively pushed the car and crashed, right? Then immediately you can explain why two objects in a vacuum, when it is dropping, it is reaching the ground at the same time, because of the concept of free falling, because of the concept of not having air resistance. And you can talk about the mass, and you can talk about the weight, right? Because there's a max, which is representing the mass, and weight is representing the weight, right? Then momentum, and so on and so forth, right? You can talk about the quantities, right? TT speed to city of Alexandria. So isn't that easy compared to remembering this text? And especially after 2 weeks, I'm sure you forget it, right? And imagine you're going to an exam hall and you are not only just need to remember the content really in this chapter. You have 13 chapters to remember for this physics, Form 4, you have 6 chapters. Form 5, you have 7 chapters. So in total, 13 chapters. So is it easier to remember these 13 chapters and this is only one chapter, the text? Or is easier to remember these 13 pictures where you have already drawn this like 20 times before you go for your exam, right? So that's the reason why this picture is important. And that's the reason why this story is important and why this story is important. Because once you are able to draw this picture, for sure you'll be able to remember this story. And with that, you'll be able to remember the drawer, right? Okay, next. I hope this is clear. And by the way, I do not see you guys. I hope everyone is still with me. It's not too boring that you fell asleep. And I really hope that this is, you feel that you feel, not me, you feel that this is giving you value. You are actually spending quality time in this 1.5 hours so far, and you indeed learn something, right? And one more point is, again, I'm not your tuition teacher. I'm teaching you a study method. This physics is a byproduct of this 2 hours lesson, 2 hours class. My main objective is to teach you the study method. And this study method is breaking down into these 10 steps. And now we are in step 7, right? Okay. So now, step 7, how do we do this? There are 10 quiz questions. How do we do this? With the picture that hopefully you have drawn and it's right in front of you. And if not, if you did not draw the pictures, this diagram, this drawing, then hopefully you have already written down these stories, right? And why this is important? Because in the quiz question, when you read this quiz question, I need you to do 2 things. One is to ask yourself which drawer this belongs to, right? So obviously this belongs, if I read this out loud, explain the primary difference between distance and displacement in the context of linear motion. Obviously this is really, by now you should be able to tell me that this is drawer number 1, right? Linear motion. And drawer number 1.1, which is the key quantities, distance and displacement. And by now, okay, that's the first thing that you need to do. Read the question and ask yourself which drawer is this, using the resources that you have in front of you, which is the picture, the drawings, and also the stories of the drawings, right? Number 2, before you read the answer, in your brain, formalize some answers. You don't need to be a very formal answer or very structured, just some keywords, right? Some keywords just by looking at your pictures or looking at this reference. You see, step 2, I'm going to, yeah, like this is step 2. So how do you able to formalize, or not formalize, make some answers to explain these questions, right? So once you have done that, then only you read the answer. Then you try to compare the answer that you have done just now in your brain in 10 seconds compared to this answer that you are reading right now in front of you. Is there similarities? If there is, good. You understood the answer and the question. If no, it's fine. So now you learn new things that you did not know before, and take this new thing and put it inside your brain drawer. All right, and this brain drawer is drawer number 1. Okay, I hope this is clear. So let's do this drill for, let's do 1 minute first for question number 1. Read the question, ask yourself which drawer, make your own answer. Then compare your answer with the answer that is provided. Let's start now, 1 minute. 10 seconds. Siming, I just saw that you raise your hand. Do you need to ask any question or you press it accidentally? Okay. If you want to ask any question or anyone here, not only Singling, just turn on your mic and ask. Don't worry. Okay. Now, do the same thing. Do the same thing. Read the question. Ask yourself, which drawer is this? Form your own answer. Then compare your answer with this answer. So let's do it in 1 minute. How do you form your own answer? With your drawing and with the story. And also this reference here. So this is drawer number 2, right? Newton, the new mummy, the new of the new mummy. And it's about the Irene, the lazy fat Irene. Okay, let's do a bit quick, a bit faster here. We'll do 1 minute for 2 questions. Let's start now. Ten seconds. Question 2, 3 and 4. Right? 5 and 6. 1 minute starts now. Ten seconds. Right? 7 and 8 starts now. Okay. 9 and 10, the last one, starts now. Okay, before we go to the easy part, which is watch the video, let's do a quick revision quickly. Okay, let me pull this out, make it wider. Right. Let's read step 2, which is always our reference from here, point number 1, drawer 1, until here, this formula, collision or impact. Let's read this by yourself, and then you ask yourself, do you feel that you understand much more compared to 2 hours ago? Right, I'll give you 1 minute to read. Okay. Just now, what time did we start? We started at 6:07. Okay. At 6:07, when you first read this, how do you feel? I think you feel a bit anxious. You saw their formulas or equation that you do not know. You read these key quantities and you're worried, how do I remember these 5 terms? Newton laws, what is inertia? Never heard of it before. What is this formula for momentum? And I have no idea what is, and also what is these equations? And what is free fall and impulse and impulsive force? You have no idea what is this at 6:07. But now at 7:49, less than 2 hours, now you are quite confident after reading this just now. What is the content of this chapter? I hope and I believe you have the same feeling as I do, right? And you can in fact, now if someone asks you, can you explain what do you learn about this chapter? At least, to the very least, you can tell them there are 5 very important points that you need to know in this chapter, which are the linear motions, Newton laws, momentum, gravitations, and impulse. And how do you know this? How can you remember this? You can remember this easily with this simple story, right? Once you explain that, then you can break down into different drawers. And that is where the drawings plays a role. Then you can start to explain to this one of your classmates what is linear motions, right? What is linear motions? In that drawing, remember the drawings where you have TT, speed to city of Alexandria. Okay, so you can explain slowly. There are key quantities in linear motions, and there are 5 of them. PT is distance. displacements. Then you can explain what is distance, what is displacements. You can explain in terms of the quantities, whether it's scalar quantity or vector quantity. You can even explain what is scalar quantity or vector quantity to this classmate. Right? Then you can explain speed and velocity. Then you can explain accelerations. Then you can also further explain the slope and the muddy area. What is this? Right? So these are the type of graph, and this type of graph for the gradients, different type of graph will have different meanings. For the area, different type of graph will have different meanings. Right? So that is drawer number one. But what about drawer number two, which is the Newton law? And the drawing in the Newton law is what? A fat, lazy Irene forces Alex's mama repeatedly acting cube. So there are three laws over here. You have the inertia, you have the force and acceleration, you have the action and reactions, right? Then you can slowly explain what is inertia. You can slowly explain what is this second law, F equivalent to ma. What is F? What is m? What is a? Then you can slowly explain the third law, the action and reaction. You can use the example that you have read just now, the rolling boat, as an example, right? Then you can continue with the momentum, continue with the gravitations, continue with the impulse, right? So is that drawing important? Yes, it is. Is this story important? Yes, it is. Because that is the starting point. That is the starting point when your brain has something to anchor, right? Once your brain has something to anchor, and then that is where you'll be able to recall what you have learned, right? Now, let's go to, I hope you have the same feeling, and I hope this is, you feel the same value by giving me two hours to teach you these methods. But before that, we haven't finished yet. And these are the two steps, this easy one, watch video. Let me just open the video. Wait, I think I need to do something.
Does it all work? You know, from
can you
a tiny
hear?
ball.
Can you hear the lady who was speaking just now? Just to make sure you can hear the video. Yes. What about Aiden? Marcus also. Okay. Now, how do you do this? Every step there's a technique behind this. For Aiden and Singling and Wong, I think you know this. For Marcus, just for your benefit, how do you do this? It's very simple. Remember the 5 drawers. Every time when this lady is talking about something, ask yourself, this piece of information or this piece of slide is related to which drawer? To give you a hint, usually they are in sequence. So it started with linear motion, which is the drawer number 1, then followed by the second drawer, which is the Newton law, then second by the third drawer, which is the momentum, then third drawer, gravitations, fourth drawer, no, even I got mixed up. Yeah, following the drawers, right? So Lina knew mommy gave invitations I kept inside my purse, right? So inside my purse is the impulse. Lina is new linear emotions. New is Newton. Mommy is momentum. Gave invitation is gravitations. Then impulse. Yes. Right. So let's do it. Let's start now. How many minutes? 7 minutes. Let's start now.
Rolling across the floor to a planet spinning through space. Everything follows a very specific set of rules. Well, today, we're going to pop the hood and look at the engine of the universe. We're opening up the instruction manual for motion itself. So to get us started, let's think about a modern little puzzle. Picture one of those personal transporters, you know, the self-balancing ones. It has no gas pedal, it has no brakes, so how on earth does it work? The person just leans forward to go and leans back to stop. It feels like some kind of magic, right? But it's not. It is pure, unadulterated physics, and trust me, by the time we're done here, you'll know exactly what's going on. All right, so here's our game plan. First, we'll learn the basic language of movement. Then we'll get into the big stuff, Newton's universal rules. After that, we're going to explore the amazing power of momentum and gravity. And finally, we'll see how it all comes together in the real world of collisions and impacts. Sound good? Let's go. Okay, first things first.
Drawer number 1, linear motion.
Before we can really dig into the why of motion, we need to get on the same page about the what. We've got to learn the vocabulary, the basic language that physicists use to describe how things move around. Now, you might think these two words, distance and displacement, are the same thing. But in physics, they're totally different. Imagine you hop in a taxi. The distance is what the meter reads, right? Every single turn, every block. Let's say it's 83 kilometers. But your displacement, that's just the straight line from where you started to where you ended up. Maybe that's only 57 kilometers to the east. So one tells you how far your tires rolled, the other tells you how much your location actually changed. Big difference. And these ideas, they build on each other perfectly. Speed is easy, right? It's just how fast you're going. But velocity is speed with a direction. 100 kilometers an hour is the speed. 100 kilometers an hour north, now that's a velocity. And then there's acceleration. That's any change in velocity. So yeah, that means speeding up, but it also means slowing down or even just turning a corner. Any change at all. Okay, so we've got the language down. Now let's
Drawer 2, Newton's law.
get to the rulebook. I'm talking about Newton's laws. These are like the source code for the universe, explaining exactly why things move the way they do. So Newton's first law is basically the universe's law of laziness. I love this. It means things are perfectly happy just doing whatever they're already doing. If it's sitting still, it wants to stay still. If it's cruising along, it wants to keep cruising. And it will not change unless something comes along and forces it to. And this stubbornness, this resistance to change, has a name: inertia. And here's the key: the more mass something has, the more inertia it has. Think about it. It's way harder to push a bowling ball to get it started than a football, right? And it's way harder to stop it once it's rolling. That's because the bowling ball has more mass, so it has more inertia. It resists change more. Now, the second law, this is where things get really interesting. This is the one that connects the dots. It gives us the actual math behind what happens when you push on something. It tells us exactly how motion changes when a force gets involved. And it all boils down to this absolute superstar of an equation: F equals ma. Force equals mass times acceleration. This is the heart of it all. Want to make something accelerate? You got to apply a force. And if you want more acceleration, you either need a bigger force or you need to push on something with less mass. It's that simple, but it's powerful enough to calculate pretty much everything. And the third law, it's just so elegant. Basically, you can't touch anything without it touching you back. Every single push or pull has an equal and opposite push or pull. Forces always come in pairs. When a rocket blasts off, it pushes gas down, and that gas pushes the rocket up. Action, reaction. Okay, so now that we've got these
Drawer
laws down,
3,
we can talk about a really cool concept: momentum. This isn't just about speed. This is about how much oomph something has when it's moving. The formula is super simple. Momentum is just an object's mass multiplied by its velocity. I like to think of it as mass and motion. Have a ton of momentum because it's really heavy, or because it's moving incredibly fast, or both. So let's put it to the test. Which do you think is harder to stop? A car that's speeding along, or a massive lorry that's actually moving a bit slower? Well, when you look at the momentum, it's not even a contest. The lorry's incredible mass gives it more than 7 times the momentum of the car. That means it has way more oomph and needs a much bigger force to bring it to a halt. And here's the really mind-bending part about momentum: you can't create it or destroy it. It's conserved. All you can do is move it around. So in any collision, the total amount of momentum before and after is exactly the same. Think about a rocket again. Before it launches, its momentum is 0. As it shoots all that fire and gas downwards with a huge momentum, the rocket has to shoot upwards with an equal and opposite momentum so that the grand total is still 0. Incredible, right? All right, let's move on to the force that we all know,
Drawer 4, gravitations.
that we all live with every single day, the one that keeps us from floating off into space. Let's talk about gravity. So here's a question people have been asking for thousands of years. If you drop a bowling ball and a feather at the same time, the bowling ball hits the ground first, no question. So heavier objects fall faster. Case closed, right? Well, not so fast. The brilliant Galileo figured this out centuries ago. The only reason the feather falls slower is because of air resistance pushing up on it. If you could get rid of all the air, if you dropped them in a vacuum, they would fall at the exact same rate. They'd hit the ground at the very same moment. Here on the surface of the Earth, that acceleration due to gravity is basically a constant. We call it g, and its value is about 9.81 meters per second squared. What that means is for every second something is falling, its speed increases by another 9.81 meters per second. That's the constant pull we all feel. Okay, we're on the home
Last
stretch.
one.
For our final piece of the puzzle, let's see how everything we've talked about force, momentum, acceleration all comes crashing together, literally,
Remember the story? Imran pushes impulsively and crashes the car. Yes, that's the one.
in the world of collisions. When things collide, we talk about something called an impulsive force, and it all comes down to how quickly momentum changes. If you have a huge change in momentum that happens in a tiny fraction of a second, you're going to get a massive, massive force. And this is where knowing physics can actually save your life. If you want to make an impact less damaging, the secret is to make it last longer, increase the time. When you land from a jump, you bend your knees, right? You're extending the time of the impact to reduce the force on your joints. Cars have crumple zones designed to do the same thing. They collapse over a fraction of a second to extend the collision time. That little bit of time makes a world of difference. It's the whole principle behind airbags and seatbelts. So there you have it. We went from the basic words to the fundamental laws, all the way to how these things play out in the real world. And that personal transporter from the beginning, it's not magic at all. When the rider leans, they shift their center of mass, creating a force that causes the transporter to accelerate to catch up. It's just F equals ma in action. We have the instruction manual for the universe. The only real question left is, what are we going to build with it next?
All right. 7 minutes. Okay, let's stop this. For the sake of time, we will skip the podcast. Podcast is a reinforcement of what you're going to learn. Okay, let me see. Maybe we can do the podcast. Okay, I see a clap of hand from Marcus. I think that you also feel that you learn something something good for you. Now let's skip the podcast. Let's do the test. Let's do the test. What I'll do the same thing like what we always do before. I will just upload. Okay, put this out, put this in, make it easier. ChatGPT. I'll upload the textbook for one chapter, for this chapter, into the ChatGPT. Okay, this is Physics Form 4, Chapter 2. Create 10 MCQ and ask me one by one. Right. So imagine that you are now in an exam. No, it's still uploading. Okay. So this is exactly what Xingling studied at school. This is the textbook of Malaysia syllabus. So imagine that you are now going to the exam. Let's generate this first. You're now going to the exam, and what you have is you have this picture with you. Where's the picture? Where's the picture that we draw this down? Yes, you have this picture with you, and you have this story with you. No, this is another one. This is biology. Sorry. Yep. Okay, you have this picture, you have this story, and you are going to an exam. Right. So let's see whether you are able to answer it correctly. Right, with this picture and story. And wait, let me take one more thing. Okay, I assume you have the picture and the story with you in front of you, because in this screen is too small, I cannot show you everything. I will use this reference. I think reference is more important. Okay, so the reference is here, and the picture and the story is in front of you in your paper. Then with that two reference, one is this one that you see in your screen, and the other one is the one on your paper. Let's see whether you are able to answer the question correctly. All right, so how do we do this? Ask the questions, read the question and ask yourself, which drawer is this? All right, which drawer and what is the answer? Okay, let's do this. In the chat, you can do this. Let's say drawer number one. Drawer number one, okay. Question one, drawer one, answer A, for example. Okay, I type it in the chat. Let's do this format. See, question one slash drawer one slash A is the answer. Let's say A is the answer. All right. So let's do this. Let's do this quickly. Aiden and Xingling. Okay, and even Marcus or even Wong, if you want to take part in this question and answer. All right. So we have B. Aiden, you have any objection or any feedback from your side? What do you think? Let me wait for Aiden. I just want to make sure that he's here with us. Okay, so answer B, let's see. Correct, right? Which statement best describe distance? The total length of the path traveled by the object. Okay. So question two, let's do the same format in typing the answers. So which drawer, which question, which drawer, and which answer? Give me two questions. Q2 and 3. No. Okay, so I have two questions. You can answer any of the questions or you can answer both of the questions. Okay, then you can try to answer any of the questions or both of the questions. I see Marcus is typing. Yes, Marcus, let's do it. Okay, Aiden, question 3, velocity. Right. So I assume if I put it into my format, 3, then you should be writing 3 slash, I assume you know this draw 1 slash velocity what C. Okay, so like this. Okay. So Xingling is question 2, drawer 1, and C. Okay, question 2. Okay, 2 is C, 3 is it C? Let's wait for Marcus. Marcus, are you typing? Yes, C and C. Okay, let's try. All right, so far so good. Okay, we have 2 more questions. We have 10 questions in total. So now it's question 4 and question 5. Let's do the same thing. Don't forget, you have to tell me which drawer. Huh? Marcus, you have to tell me which drawer, and also Aiden. Why it is important? Because by doing this, you can remember it better. Oh, okay. Which formula represent accelerations? Why is it still in drawer 1? Right, this both are still in drawer 1. Okay. But I did not control the type of questions because it is done randomly by the AI. So number 4 is B from Xingling. Anyone want to try number 5? In a velocity time graph, the area under the graph represents the area under the graph represents velocity time graph, the area. Check on the reference. Look here. Look on this reference. Is there any answer over here? Xingling, you want to try? Give a guess. Aiden, you want to try? Acceleration, distance, displacement, velocity. Okay, remember, this is the story of TT speeding to the city of Alexandria. And there is this slope, high slope, and muddy area. Right, so this is the particular part on the area, the muddy area. And the muddy area, what is the answer? What's the answer? Draw number 1, still draw number 1. Still draw number 1. Area for velocity time graph. Right, the graph, there are 3 graphs. And we need to know what is the area for the velocity. C, yes, let's see whether it's C. Okay, correct again, good. Now, question 6 and 7. 6 and 7. Aiden, try, Aiden. Try to focus one questions. Which of the following situation describe uniform velocity? Still draw 1. Still draw 1. An object is in free fall when, this is draw 4, gravitations. Next. Okay, we got answer from Aiden. Next 3 question. Need to get it from Newton law, momentum, and impulse. All right, B and B. Drawer 1, yes. So 6 is B, 7 is B. Is that right? Is that right? Question 7 is B, free fall. Okay. Okay, what about Xingling? Xingling, what do you think? Question 6 is B? Okay, no answer then. Okay, let's wait for Xingling. I see Xingling is typing. Question 6 is B for Marcus. Xingling, are you still typing? Okay, for the sake of time, we will see whether it's B. Right, it's not B, it's C. Why is it C? Uniform velocity means the object covers equal distance in equal time interval, meaning velocity stays constant, no acceleration. Okay, right, it's good. So there's new information that we are learning from this new answer. Okay, so next, 3 questions, and I intentionally asked them to change it to the other drawers, not just to focus on drawer number 1. So question 8, 9, and 10. Which statement describes Newton's first law of motions? I remember the fat Irene, fat, heavy, lazy Irene. Then the formula for momentum. Okay, 8 is C, the fat, lazy Irene, right? Formula for momentum is also drawer 2. Okay, Newton law is drawer 2, yes, not drawer 1. Good, so I see that you corrected it. Okay, question 9. The formula for momentum is, this is very easy. I think you see this formula like 200 times over these two hours. Question 10. Impulse is defined as question 9, drawer 2, answer A. Question 9, drawer 2. Marcus, what is drawer 2? Drawer 2 is Newton law, right? Momentum is drawer 3. Okay, no problem. It's a small correction. Question 10. Yes. Oh, yeah. Yes. So now you remember drawer 3 better. Okay, Xingling is typing. I'm waiting for Xingling. Or anyone, Aiden or Marcus. Don't worry about getting the perfect answer. Wrong answer is also a good answer. Just like Marcus did. Now Marcus remember drawer 3 is momentum after typing the incorrect answer. It's part of the learning. So now question 10. Hurry up. Anyone? Just give a guess. At least which drawer? Question 10 drawer. Drawer 5, yes. A. Okay, let's see. I think the answer is correct. Yes, all 3 correct. Right. So you got 9 out of 10. These are, to be frank, these are easy questions, but you only, how long did you take? You take 2 hours or 2.5 hours to now at least to understand what is in this chapter, right? How do you remember what is in this chapter? if somebody asks you tomorrow, you're going to come back to this story again. Lina knew mommy gave invitation card and I kept it in my purse. And with this story, you can remember the name of the drawers. By just remembering this name of the drawers, I'm sure by now you can already have you can already explain what is linear motion, what is Newton's law, what is momentum, what is gravitation, what is impulse, right? Because you have this drawing with you. Remember the drawing that you have? And that drawing is the, where is it? Yes, this drawing. This drawing and this story, right? So you can talk about a lot of things. And imagine if you have done this like 20 times, and I'm sure you'll be able to do well in your exam for the students, or you'll be able to explain well to somebody who wants to know what is force and motions, right? So that's it. Congratulations to complete this 2 hours and 2.5 hour journey with me. And thank you very much for your time. And I hope you learned something. And let's meet again next week. Next week, we will do the revision part on this. Today, I'm teaching you the 10 steps for learning new subjects. Next week is how do you do a quick revisions on this chapter, right? Thank you very much. Hope to see you next week and hope you learned something new today. Bye-bye. Thank you, Marcus. Bye-bye. So I'll leave now. Bye-bye.